Okay, we are live.
All right, we are reconvening our morning meeting and shifting gears again to the topic of a feasibility study to reintroduce cougars. And we welcome representatives from Panthera. I believe Mark, you'll be the main presenter, but Emily, did you want to open up with anything or? No, great. All right,
No,
welcome,
it's
Mark.
totally okay. Yep.
Well, thanks very much. Shall I just dive right in?
Yes, please.
All righty. Going to share a presentation as well. Get that moving. So just to introduce myself, I put a couple of links. Everyone all right? We good?
Yes.
Yep. Okay. I just getting some echo. So yes, just to introduce myself, there's some additional notes about myself and the information that are in the actual presentation in the notes in the sort of PDF version I sent you guys last evening. So feel free to look there as well. But just to introduce myself, my name's Mark Elbrock. For the record, I work for an organization called Panthera, which is a global science and conservation organization that's focused on wildcats and the habitats in which they live. And I am, in my role in the organization, is the director of the Mountain Lion or Puma program. And my job essentially is to come up with the conservation strategy that we follow and pursue in North and South America to conserve this species. I have been working with mountain lions for over 20 years and across 3 countries and numerous sites. I am also the current lead for the IUCN assessment of their extinction risk globally. And I run a sort of diverse group of folks of about 18 representing 14 countries and sort of assessing their conservation status at the global scale. So that's something, just a little bit about me. What we're going to do today is I'm here at the invitation of the committee, which I appreciate. Absolutely thrilled to be here. And we're going to walk through about mountain lions, but also talk a little bit about some habitat research that we've done in a cooperative group, which I'll introduce shortly. I just want to say I'm absolutely thrilled. I've been reading up about Vermont. I'm calling in, for those who aren't aware who I am. There are no mountain lions, at least breeding populations in Vermont. So I'm not calling in from Vermont. I'm calling in from the West Coast. I live in Washington State right now, which is actually a landscape really similar to New England. As a former resident of Vermont myself, it's sort of that rural landscape where people have 5, 10 acres, a couple of chickens in the backyard. We choose to live in these landscapes because we want to be in a rural landscape and chop our own wood and live, that sort of lifestyle, which is I think akin to the Vermont traditions that I remember. And in reading about the state, I was just absolutely thrilled to see that the mountain lions were included in the last Wildlife Action Plan, which was published in 2015, currently under revision, and that there were actual high and medium priorities set for the species at that time. So that's a great place to begin. Today, we're going to do a mountain lion primer, which was sort of the invitation I received, is to talk about the species. And I'm going to boil it down. You can kind of get lost in natural history of any animal. And I'm just going to give you 12 what I think are key facts to begin to build a foundation for understanding this animal. And then we're going to do a review of the habitat work that we've worked on. I understand you've seen some of it, so I'll try to really talk more about the nuts and bolts of it. How did we get to where we were, and what was the methods that brought us to the conclusions that we shared in that research? So I like to begin with a video very briefly, but this is the cat of many, many names. It has hundreds of names across its range. It has the world's record for the most common names, and so it's good to have an actual visual of the animal so that we all know what we're talking about. Locally in Vermont, often called catamounts, across the United States, most often called mountain lion, but you also hear Florida panther for the part in the southeast. And of course, cougar in most of Canada. And in fact, it's most commonly used in Washington and Oregon as well. Around the world, it is most often called puma. and they are much like house cats, except a heck of a lot bigger, and that they can kill prey 10 times their size. So here's the first of my sort of 12 big facts about the species. And again, there's a little citation in the corner, but if you look on your notes, there's the actual full citation if you'd like to follow up and read about any of these topics in greater depth. But the first thing I like to emphasize is that mountain lions are highly connected species, meaning that they have direct relationships and indirect relationships with many, many kinds of flora and fauna. And so in this review, we found that they had direct and indirect interactions with 485 different kinds of flora and fauna. And the reason I like to emphasize that is that it really emphasizes that this species is one that absolutely contributes to biodiversity and the sort of ecological health and resilience of ecosystems. Number two, overall, mountain lions eat all sorts of things. Well over 200 kinds of prey have been documented across their range. But in any population, most of the individuals will specialize on the most abundant hoofed animal. So that might be a white-tailed deer, it might be a llama species like a guanaco or a vicuña in South America. It could be elk if they're more numerous than deer. And this is representative of their prey that they take across their full range. So this is not an individual's diet. This is mountain lions in general. They eat, and it's just to represent the great diversity of prey species that they take across the range. Reptiles, amphibians, primates, fish even. We just documented fishing here on the Olympic Peninsula, which is super exciting. Number 3 is, as a species, their temperament is that these are incredibly curious animals, but they are absolutely ruled by caution. And I like to show this brief clip cut by Jeff Hogan. This is an adult female mountain lion that was part of our project in Wyoming. And she just got up out of bed. She's all alone in the woods, and she just starts playing with this stick. And it's an amazing insight into what this animal is really like. And I think it helps break down some of the sort of mythology around the species. These animals are far more cautious than many other species. The analogy or the I like to share with folks is, even though I've climbed in numerous holes, bushes, under decks with mountain lions, and I continue to do so, I would never want to do that with a bobcat. And they just have very different temperaments. So that sort of gives you a sense of what this animal is. This is an important one. All the research to date suggests that they hunt livestock opportunistically. And what that means is that they are actually looking for their primary prey, which is deer or elk or guanacos in the south. And if they encounter something else, that could be a porcupine, it could be a goat in someone's yard, then that presents the opportunity that they might include it in their diet. Livestock is a tiny part of their diet anywhere you look at them, but the big message for us in the US is that when we have domestic animals in what might be called deer habitat, and we have to sort of recognize that in these rural landscapes where we live, that our backyards are in fact deer habitat, especially if we're feeding deer, we need to protect our domestic animals. And so that really can stop or mitigate, essentially all of the conflict that can occur in backyards. To speak directly to the kinds of conflict that mountain lions have with people, in the US, our conflict primarily occurs in backyards. Mountain lions are not an issue for large ranches. So you don't hear about them, in Wyoming going through and hitting a cattle ranch with 3,000 head or something like that. That's not the purview of mountain lions. Where conflict occurs for this species is in people's yards. It's people that own 2 goats, 3 llamas, an alpaca, 6 chickens. Those are the places where we see conflict occurring. And it's when these animals occur in deer or elk habitat and they leave them unprotected. Again, a different kind of conflict is attacks on people. I would just emphasize that these are exceedingly rare. And yet, and it's in part because of their rarity, they are highly sensational. And so there's wide press coverage of any attack that occurs. In the state of Washington, 2 people have been killed by mountain lions in the last 130 years. I put additional numbers in the notes. Social science would suggest that sharing numbers doesn't actually alleviate people's fears. So I'm not going to continue to go on, but in your head, you can recognize that, the huge numbers of people that die every year running into deer from dog attacks, all these other ways, lightning bolts, and yet mountain lions are not anywhere near as risky. Where they occur, at least in the US, or especially the US, since that's where we're talking about, is attacks on people. The few that have occurred don't happen in people's backyards. They have occurred far from people, generally in wilderness settings, and it's generally where people are recreating, biking, mountain biking, hiking, that sort of thing. That's kind of the place where that kind of conflict tends to occur. As a species, coming back to that, mountain lions are incredibly family centric. I think far more than anyone had ever really realized until the last 10 years. A female spends about 82% of her life in the company of kittens, multiple generations of kittens being born with her. I'm just gonna, move this. Oh, I should get rid of that. And just give you a sense of what these families are like. These families are highly interactive. They are incredibly physical with each other. There's lots of touching, cuddling, rubbing, purring. These are the largest cat species that can purr. So purring is constant, especially when the kittens are small. This is how they greet each other. This is the one that has the collar is the mother. And she's been away from this young female for about 20 minutes while she fed on a nearby prey. And they just welcome each other, reconnect with each other after that absence. And then the mom goes and lays down to take a break. There's another version. This is just another example of what she's like with her male kitten. And he's already larger than her at 14, 15 months old. And yet she comes and he had been away 20 minutes and she reconnects with him physically so that that bond is strong before they lay down again and take a break. So mountain lion populations are not all composed of the same kind of mountain lion. And one thing that's important to recognize when we talk about this species is that there are different categories of mountain lions, if you will. And so in general, we talk about there's a proportion of the population that is adult males. These are, the big resident males. They hold a territory on the landscape. We're going to talk about the importance of that in just a moment. There are adult females that are also out there. They all have territories as well, or home ranges, some people call them. And these are big areas. Female home ranges, generally are about 50 square miles, 60 square miles. Male home ranges are an average or 150, even 200 square miles. Sometimes, there are exceptional cases of larger home ranges than that. And most of these adult females will be in the company of kittens of different ages. Some of them might be newborns and some might be a year old because they tend to stay with their mom for about 18 months. And then there's a portion of the population that we call either transients or dispersers. And these are kittens that have left their mother but have yet to establish a territory. And this part of the population is kind of always in flux and they're on the move. They're the ones that are moving the furthest distances. They often bump into people more often because they are unfamiliar with the areas in which they're moving. So they just run into a backyard or, are following an old 4x4 track and it leads them to a town or a river bottom. Often our river bottoms often lead to people as well. So these sorts of things occur with that younger generation that's trying to find new places to call home. The next thing is that mountain lion populations are actually broken down into smaller social units that I would loosely call communities. And they are governed, if you will, by territorial males. The sort of placement on the landscape of what a community looks like actually is delineated by the territory of an adult male. And in that community, that adult male overlaps multiple females, 3, 4 females with which he has constant sort of interactions. Sometimes they share food, they're hunting the same deer and elk herds, they walk the same trails, they know each other and are in constant communication. And then next door is another community, which is sort of has the same structure. And the interactions across those communities occur, but far less often than the interactions within a community. So when you picture a population of mountain lions, I no longer sort of describe it as just seeds thrown out on the landscape. They're not uniformly spread randomly on the landscape. Instead, picture social units spread across the landscape. So they fit together in ways that look like a mosaic of jigsaw pieces, kind of like the colors on the side there. That's a big territorial male. These communities add up to populations, which we just talked about, and populations are connected by dispersal. Oop, I went one too far. So in this image is supposed to depict 4 different populations represented by different colors, and the arrows are to show you the importance of dispersing animals. Those dispersers are transients, youngsters that move from one population to another. In the past, populations were divided mostly by huge environmental boundaries, like a huge river. And I'm talking a big one, not a little river, because they can swim up to 2 miles, so it's got to be a major river. That's more common in South America. It's got to be a huge, really dry desert. That happens in the Western United States, or a huge sagebrush flat, because out there they're super vulnerable to wolves. So historically, those would break apart populations. And then these dispersing animals, these youngsters that are just adventurous and open to greater risk than adults, they navigate these landscapes to connect these populations. Today, it's all about big roads. Our big roads, our big highways are really the primary boundaries that are dividing the new populations of mountain lions in not just our country, but everywhere. One thing I like to emphasize too, especially for wildlife management, is that when you add all these populations together, we call it a metapopulation. And that exchange of individuals but among those populations is essential to the genetic health of that population, its long-term survival, but it also makes it really resilient to human impacts. And in the West, human impacts typically means hunting, because most states hunt mountain lions. And if you're hunting a population and having a sort of a negative impact, meaning that you are driving the abundance of mountain lions down in a region, as long as they are connected within a meta population and the other populations aren't being driven down in the same way, they can support immigration into that population to help it recover. So that meta-population dynamic is super important to sort of long-term health and resilience of mountain lions on a larger scale. And last is just something for us to consider as we contemplate the bill that you've proposed is they're currently absent from close to 2/3 of their historic range in the US and Canada. This is the largest range contraction for mountain lions anywhere in their full range in North and South America. And of course, that's due to, what we did with carnivores hundreds of years ago when the US really were a different people with different cultural values. So with that, I thought I would transition and talk through this research and, hopefully give you guys ample time to ask me questions in whatever direction you'd like to go. What I'm about to discuss is, I know you've seen some of it, or maybe all of it. I'm going to focus on the sort of mountain lion habitat stuff, not the social science, which I know you will hopefully hear directly from our social scientists very shortly. But this is collaborative work done with multiple organizations, lots of people, but we represent Northeast Wilderness Trust, located in Vermont, Panthera, Tompkins Conservation, Michigan Technological University, the Ohio State University as well. And then we pull in others as well as needed. So the three things we're going to talk about right now are our initial objectives as a working group. We came together, we were interested in exploring the idea of whether mountain lions could return to the east. And so we had very simple questions to begin. Is there habitat in the east? Are there large contiguous blocks that could support healthy mountain lion populations, even if they were disconnected from other mountain lion populations in the West, so that they could maintain their genetic health and vigor over time? If they're already on their way, because some folks would say, well, let them recolonize on their own, how long is it going to take? Those are our three big questions, and I'll talk about those now. So again, I'm going to try to talk more about the nuts and bolts to kind of bring clarity to what we did and why we did what we did. So in determining whether there's habitat, there's lots of things we could have done. Most folks who've looked at habitat in the East are based on what's called an expert-based model. Basically, you find people who know something about the species, you ask them lots of questions, or they fill out big spreadsheets. I've been involved in this kind of work myself, where you say, do they like Doug fir forests? Yes. Is that a good habitat for them? Sure. Do they like railroad tracks? And you just literally go through and describe how they use all of these different habitats, and you use that to build a model to predict where you might find these animals. What we did is different in that we apply what's called a resource selection function, and it's based on the actual locations of mountain lions studied in research in the West. And one might argue that that is a stronger or more defensible approach than using an expert-based model, which is sort of our version of what we think mountain lions do. We're letting the mountain lions tell us the habitats that they prefer. And so what you do when you apply a resource selection function is you have locations, at least for animals wearing GPS colors, and they're represented in these colored dots up in the upper panel there. And so these are actually elk from a paper I just took some maps from. And you say, these are the places where the elk chose to be. We know where they were. They were in certain places, and we can look at all the environmental conditions in which those places were, what it looked like, what kind of trees were there, was there an understory, was it near a river, all of these kinds of things. How close were they to people? And then we can compare it with the areas that they weren't. And you basically have these two categories of data, and through that you build a model to say, what are the characteristics that predict where elk will be? And you build that model to predict out or extrapolate from the data you have to build a map that looks like something on the bottom. And it comes up with a probability that you'll find an elk in any location across some landscape that you project your model. And so I will speak to two limitations that are really important here. When you extrapolate out a resource selection function, the two things that are really important to consider is the diversity of sampling. So let's think about black bears. If you only studied black bears that lived in swamps, could you build a model that would predict where they might occur in upland forests? Maybe, but that's the fact that you have no data from upland forests might limit your ability to project into that habitat. So you want diversity. You want to study the species in as many places as you can. And then the other is you want as big a data set you have. The more animals you include in your research, like the original data, the better opportunities to project more accurate maps or sort of to better predict potential locations you might find a particular kind of animal. There's been one other change in resource selection functions that's quite new, and this is what we actually did. And they're now called step selection functions. And a lot of folks, used the RSFs early on, and there was one other criticism is that can we make these more biologically relevant by limiting the data that we compare with the known locations of an animal? Because we know, like, I don't know if you can see my little cursor. Can you see that? Everyone see my cursor? Yep. So these are the places where an elk was. Should I compare a location for this elk with this one, which is that elk can't even go over there. It's not part of its territory. It's so far away that it doesn't seem biologically relevant for this species. And so step selection functions have built a new set of models that compare, here's a mountain lion as he traverses the landscape, and we only compare the location where the mountain lion chose to be in a given point in time with locations that were biologically defensibly possible that he did not choose. And then this is what's called the step length to the next known location. So you only compare that with some biologically defensible options that he did not choose around that step. These are computationally much more difficult to process in a computer. But as computers have developed over the last 10 years, these sorts of analyses have become possible because you can now imagine that you're now analyzing at each step an animal moves a series of options that it could have taken but didn't. But it makes for a much more biologically defensible approach to predicting habitats on a larger scale. We gathered and amassed the largest data set for this species ever. We were able to bring in 2.5 million locations from Western mountain lions across the West. 20 different study sites contributed data, each with a collection of animals that use different parts of their study areas. And we built that, and we, could, because of the size of this data set, we were able to look at lots and lots of covariates that might explain why a mountain lion was in a particular place and not in another. And we were able to do that super defensively. All of this in this column here are all the research papers that support the idea of including all of these different biotic covariates and human impact covariates. And we don't need to go crazy in the methods, but I can tell you that in the end, we learned that we could predict a mountain lion's location very accurately, and that prediction was based on lots of covariates contributing to that decision. So we have everything from elevation NDVI, which I know you've had some background information about, but it includes the road structure, human population density, everything. All of these things are contributing to the prediction of where mountain lions are across this entire landscape. We went one step further. Well, this is the map that was produced. I know you've seen this before. The bluer is a higher probability of finding a mountain lion than the yellow, which is the lowest. And yes, the east has lots of blue, which suggests there's great habitat in the east. This isn't really unexpected. Anyone who studies wildlife knows that deer, that black bears are super dense in the east because of very, very productive ecosystems in the east as compared to the Western United States. We did go even further, though, just to attempt to validate our methods. And this is called a leave one out analysis. And what it does is, because we had 20 different study sites contributing data, we would withhold a study site, rebuild the model, run it, and see if it could still predict where mountain lions were in the study site for which we didn't include the data. And we did that for each of the 20. And then we took the average, and you can see it's an amazing, essentially 93%, which means that it had incredible predictive ability, even in places for which we didn't include the data. So that's a really important thing. And that gives us faith that this model and the map projection is accurate even in areas for which we did not have data. The next thing we did is we wanted to look at whether there were large chunks or blocks of suitable habitat in the east. We actually did this analysis first, and if we had had our RSF layer, we probably would have approached this in a very different way. But alas, that's not what we did. We did this first. And so we didn't have the RSF. We didn't know where mountain lions were predicted to be in the east. So instead, we built kind of an expert-based model. And we did this. That's Than Robinson was sort of leading it. He's now based in New England, working for TNC. And we went to the literature. What do we know about this species? And we began to pull out all of sort of the predictions about this species. One, that they avoid open habitats in North America. This has historically been wolf range. That's part of the reason they avoid open habitats. Human influence, of course, since we removed wolves from most of their former range, continues to sort of put that pressure on mountain lions, and so they tend to avoid open habitats. They need a certain amount of structure or forest cover for hunting. They follow deer and elk, all of which avoid deep snow. So we were able to look at thresholds of snow. For instance, it shows that most, ungulates avoid more than 50 centimeters of accumulated snow, or if that's the average winter snow depth, moose being an exception. And so we were able to put all these together to look at thresholds that might explain where mountain lions might be found in the east. And we included a lot of human density stuff, or human impact, if you will, variables to help us refine that more. I'm going to just highlight this one because I think there's been some misunderstanding about what this represents, and why we included it in this analysis. So former research has shown that mountain lions essentially avoid approaching large highways within sort of 170 meters. And so we put that in our analysis. And I just want to emphasize that this had nothing to do with road mortality. That's not why we incorporated this. What it has to do with is allowing us to better understand how mountain lion populations might be divided or subdivided by these roads. And this, I just want to show you some examples here. In black here is a resident adult male mountain lion's data for 1 month. This is 1 month of a dispersing mountain lion, a young male, is in yellow. This road up here called Highway 8 gets about 20,000 vehicles per day. This road down here, Highway 12, the lower part gets about 12,000 cars per day. Highway 5 on this side gets 100,000 cars per day. And you can see the resident male sets up his territory, and that these roads that have high traffic volumes are boundaries to that territory. Dispersers, on the other hand, will take the risk and cross big highways. So when we did this analysis, the intention was to identify contiguous blocks, meaning like what would be a population of mountain lions, recognizing that most mountain lions will set up home ranges that will not cross major highways. That's why we included that in the analysis. I'm going to give you another example of what we did to kind of build faith in this approach. These right here on this one, just look at this section right here. We took the home ranges of 379 mountain lions, and we looked at how often in their movement paths they crossed roads of 2 lanes, 3 lanes, 4 lanes, 5 lanes, 6, 7, 8. And you can see that they have no problem crossing 2 lanes. They cross them all the time. And that as you increase the lanes in general, it goes down. And then this other, whoops, sorry there. This one up here is just another way of classifying roads. So when you go into a road database in a GIS, for instance, they talk about classes. So class one is the major highways, the huge arteries that are running through our landscapes, which people drive at, breakneck speeds and have high traffic volumes. And then classes going down, the larger the number is, the more rural the road. And this is sort of the same idea. How often are mountain lions crossing these ones? Class one, the major arteries versus the more rural roads going down. So again, it shows that they will cross and utilize those smaller roads, but really do not cross, their home ranges do not cross those major arteries. And that's what the purpose of that covariate was. Once we applied all of these different thresholds, this is an urban sort of human density layer that you're looking at right here, we could kind of parse out what still remained. We applied the snow and the human density and the livestock density and all these different variables. We said, what habitats left? And then we looked at how much of it was connected. And the reason we did this is what new research suggests is that you need at least connected habitats of 6,000 square kilometers and better 10,000 square kilometers to maintain the health and vigor of a mountain lion population in isolation, meaning that it is not part of a metapopulation with other populations that it can disperse to and from to exchange genetic material. They're all alone in the world, like Florida. Based on all of that, we found that yes, there are large contiguous blocks of habitat. Whoop, I'm going to go back. I think there are the numbers. We found 17 of which were larger than 6,000 square kilometers and 13 of which were larger than 10,000 square kilometers. To talk specifically about this, I'm going to remind you that what we're referring to here is the difference between what a resident mountain lion will do versus what a dispersing mountain lion will do. The way that we ran the analysis is the major arteries were boundaries. Mountain lion populations were subdivided by these major arteries. And if the area in the middle was less than 6,000 square kilometers, it was removed as potential habitat for the species. But we know dispersers cross these highways, or at least try. And so it's really the frequency that youngsters will cross these highways which will decide whether all the blank space in Vermont and New Hampshire here is actually contiguous habitat. Because if they're frequently crossing these highways, which I have no doubt would happen in northern Vermont and New Hampshire, based on my experience with the species, I expect they'll be crossing all the time. A youngster will be born on the east side of the highway and they'll cross to the west. And that will be no problem for a dispersing youngster to do, even while the residents really stay on one side of the highway or the other. What that means for us when we talk about habitat patches in the Northeast is that very likely this one called number 5 in southern Vermont probably stretches, if there's frequent interactions or youngsters crossing highways, all the way to eastern Maine. That this could be viewed as a single huge contiguous patch instead of subdivided by these highways. We also provided a few metrics with which people could compare these different habitat patches. There's no one way to do that. And so we didn't rank them specifically. We just said, look, there's lots of ways to look at this. We could, for instance, look at livestock density. And I did circles for the 2 areas that overlap Vermont. So one of them has really low livestock density. It's one of the best if we compare among these 13. And just to be clear, all 13 patches are greater than 10,000 square kilometers. All of them meet the biological, ecological thresholds we set. All of these are suitable for mountain lions. All of them could work. But Vermont ranks super high when it comes to live dog density in one spot, lower on the other. In terms of public lands, many spots show greater percentages of public lands than the ones of Vermont. In terms of human density, yeah, it ranks, middle to lower. But where Vermont shines is in the potential tolerance for wildlife. And in this particular case, this is not based on any surveys that we did. That's coming. We'll share that with you hopefully very soon. This is based on previous research called the Wildlife Values Assessment, where they looked at people across the entire country and they looked at how people essentially viewed wildlife, whether they were sort of a usable commodity at one extreme that could just, you do whatever you want with, versus the other extreme being people that viewed wildlife as really members of a larger community in which they too participate. And that Vermont and really the states in the Northeast exhibit an incredibly high wildlife value in comparison to these other places, which makes this area shine. Because as I said, any one of these 13 areas, we could introduce cats. Ecologically, they're all great. Sure, bigger might be better, but they're all great. But it's the people that are going to make the difference on whether mountain lions can survive and grow into a full population in any of these regions. The last total size, I just want to highlight that one of the Vermont spots is right at the bottom. But if you just remember 2 minutes ago when I talked about dispersal across the highways, this area may in fact be one of the largest because there may in fact be true contiguous habitat stretching from western Vermont all the way to eastern Maine. So just consider that as you think about things as well. Last but not least, everyone says they're coming. How long is it going to take for them to get from the west to the east and settle on their own? So this is Tom Glass with the funny hat in the corner there. He led this analysis. He was a postdoc. We used an agent-based model, which gave us lots of information. That paper has been published and it is so rich. If you go through the supplementary materials, it gives you statistics on where they're likely to come from, where they're likely to land, what are the obstacles they're going to face in the middle. There's so much in there. It's really an amazing resource. Again, I'm just bringing up this picture to remind you the difference between dispersers and residents. And so we built this model only using the GPS tracks or known travel paths of dispersing mountain lions. There were no residents included because we wanted these animals to cross highways. But because we knew that they were going to try to cross highways, we had to account for the possibility that they might not survive. So in this model, I just want to speak about and really highlight Tom's work and numerous others who contributed, including myself, how much time we spent making sure that the biology was correct. A full year of emails, phone calls, amassing everything we know about the species so that we could define the regional mortality risk for this species across the entire West, that we could look at even the natural death mortality rates across the entire West. We wanted to know the different habitat patches. We wanted to know exactly where breeding mountain lions were at the moment that we were projecting our model so that we could most accurately project eastward. So there was a tremendous amount of time. How many females are born in each litter? How many females survive until 18 months old to leave their mothers and set off to find their territories? How often do they have kittens? How many kittens are in a litter? How many, on average, female kittens are dispersing every day? All of that information is what drives this model. To validate the potential accuracy of this model, we actually went back in time because in the last 25 years, these little areas in gray are new breeding populations that have popped up. They weren't there 25 years ago, but now they are. So we figured, could we go back to the mid 90s, initiate our model then, and see if it correctly projected the timing and location of these new populations popping up? This is showing you timing. The blue is where the scientists or the state biologists or whoever was in that region feels they documented the first breeding populations or kittens on the ground in those locations. And then the model is this square. If it's inside the square, that's usually really good. Here is more speculative. The local biologists, etc., were like, well, we think it's right around here, but we're not as sure. But these are like known kittens on the ground occurred in these time periods. And you can see that it really did super well in predicting the timing of these events. And here is in black is from the, again, what we called hindcasting, going back in time, projecting forward 25 years. Each of these little lines represents a disperser that survived. And where male dispersers and female dispersers could meet up in space, they could produce young. And so the darker black areas are essentially where the model projected there would be populations of mountain lions beginning in new places. And here in blue is where they actually have occurred in the last 25 years. So that, again, not just the timing of the predictions coming out of the model, but where populations would appear was incredibly accurate and gave us faith moving forward. And so that's what we did. We projected 77 years into the future to 2100. We didn't think it was really worth going beyond that because the human footprint will have changed so much by then that the covariates that we're using in this model today will become irrelevant. This is what the model projects in the next 77 years. The dark areas are where we're going to most likely see new populations. You can see in Nebraska going out to this corner, which they aren't including in this year's map, but they think they've had a breeding event already. You can see most of the growth will be in Canada, parts of central Texas, and you'll see Oklahoma and other places. Each line representing a fraction of the sample or the iterations that we ran the model, but it shows again surviving dispersal. And this is where males, actually what I'm depicting here is all females, but it's where the females are likely to interact with males and begin to produce. What we did based on all of that is we came up with we ran the model many times, and we said what percentage of those iterations produced a breeding population in each of these states. We have information for all the states. I just threw some in here, that Minnesota, there's a 30% chance that they'll have breeding mountain lions in the next 77 years, Oklahoma, 32%, etc. And one of the things we noted was that these primary roads, those class 1 roads, the big highways, absolutely get denser as you move east in our country. And that is likely a contributing factor. One thing I want to emphasize, it's really an important thing, is there is a huge difference between dispersing males, which are likely to go all over the place in the next 10, 20 years, already are. We've already seen a cat reach Connecticut in 2011. And recolonization, which requires dispersing males, dispersing females for those two animals to meet in the same place at the same time, to have a breeding opportunity, and for those youngsters to grow up and hopefully survive, and then for that to happen enough times for them to begin to build a population. Dispersal is already happening. This here is when we hindcasted that 25 years, the red are all the projected mortality of young males dispersing, some of which even reached the Northeast. This is what the model predicted. This is the Midwest mortality of mountain lions, mostly on highways during that time. And you can see they match up pretty good. This is the Connecticut cat that died in 2011, which, is cool to see that the model was even predicting that there might be a few that reach that far. And here's the what we think, or there's the suspected path of travel from the Black Hills up around the Great Lakes, or most of them, and then downward to Connecticut like that. That occurred in 2011. So again, emphasizing that these kinds of things are totally possible and have already occurred, but they are not true recolonization, which is going to happen much, much slower. Most females will die as they disperse eastward. That's just the hard truth. Interestingly, our model suggests that hunting, legal hunting or harvest in the Midwest will be the primary cause of death. You know, look at Nebraska, who's, you know, already permitted hunting of their easternmost population, which is about 27 animals. Roadkill will be the close second, and it's not unexpected given all of those major highways that they have to cross to move east. But importantly, about 9% of these females will live. And we know that there will be males where they or when they arrive. The males will lead the charge. They'll be cruising out east much faster and already are. And it's the females we're waiting for to catch up because they disperse so much shorter on average than a male does. And so we just need them to catch up to create these breeding opportunities. Yes, they're coming. I like to show this map because it just emphasizes how slow it could be. This is the Black Hills. This is what's called the Pine Ridge of Nebraska. This is, you know, 100 kilometers or 180 miles. I can't remember how far this is, but it took 20 years for the breeding population here to establish a breeding population in the Pine Ridge down here. And that's a long time. With that, I am going back to this slide. We're almost done. And I just say it's super exciting that, again, to see that there are high and medium priorities. In terms of, I sort of gave him some numbers right there. Number one, Vermont has already done this. They're maintaining the species as endangered. They're, you know, really providing the state wildlife oversight to protect this species. Identifying areas within the state that could support viable mountain lion populations. The work we've done could quickly be used to do that super well for any state interested in kind of developing those tools. A state recovery plan, I think that's, you're talking about the first step right here, would be a feasibility study, would be a critical component of that. Whoop, I went backwards, did I? 4 and 5, determining public attitudes. We've done a tremendous work at a much larger scale on the region of the East, and it would no doubt, well, once you hear more about that and the nuances of what we've learned and how to interpret that data, you're still going to need to do really focused Vermont surveys to get that answer. Providing interpretive and public educational information, we'd be thrilled. I'm sure lots of folks would be thrilled to support the State Wildlife Agency and the people of Vermont in developing such tools. I'm just going to leave you with this, which is what we're currently working on. We have a lot of social studies assessing both the tolerance for living with large carnivores as well as support for their reintroduction in the peer review process right now. Jeremy's going to come and share some of that with you. Super exciting stuff. I can tell you that what our previous work focused on the sort of comparing across states, and our new work, we just wrapped up the sampling, I think like 3 days ago, where we now have at the county level a much more refined survey conducted again across the East, lots and lots of counties, and we're going to be able to look at these questions at a much smaller scale, which will be far more useful to Vermont. But without doubt, you're still going to have to do survey work in Vermont to get specific questions, especially questions about the views of particular constituents. Mapping habitat as a combination. Oh, so this is one of the things that we're really working on now, is so far we've looked at habitat in terms of what do mountain lions need, but we want to combine human tolerance plus ecology and to really predict the best places where mountain lions could survive. We're actually going to map their, you know, sort of survival rates and their potential human caused mortality based on all this survey data as well. And all of that will make doing that kind of work in Vermont super fast and efficient. I put some additional notes on sort of my thoughts about a feasibility study, like timing, costs, etc., most efficient ways to do that as well. Thank you so much for listening. And I did ramble quite a long time. So, but if you have questions, I would be thrilled to answer them.
Thank you so much for your presentation. I'm confident we'll have questions, although we are bumping up on the noon hour. I welcome members to stay with questions, or if they need to go to another meeting, to go. I guess I'll kick it off by just asking if you could speak a little bit to the importance of apex predators in ecological landscape scale restoration. Just a small topic.
Yeah, yeah.
If you could just touch on that for now, and maybe you could, either you or someone else could come back and speak to us on that.
Yeah, I think that's it's something we're really learning about as a scientific community. It's ongoing, right? And people are super excited about using carnivores to sort of transform landscapes. And I think there's two things to emphasize, and both are about caution. So the state of knowledge where we are today versus even 5 years ago is that, yes, we know carnivores play an important role in building biodiversity, ecological resilience, all of these things. Absolutely true. However, the effects of carnivores on an ecosystem are so overshadowed by people and their impacts on environments that it takes a long time to see them and to be able to measure them. And so just understand when you bring carnivores to a landscape that it will be a while before you see any measurable changes that we could actually, see in the field. So that's number one. Let me think about that. Number two is that a lot of the sort of rewilding discussion is about bringing a landscape back in time to where it was, say, 200 years ago, as if we could do that. And what generally happens when you bring carnivores in or sort of do something dramatic to an ecosystem with the good faith and good intentions of restoring it, if you will, what happens is that it doesn't go back to the way it used to be. It goes back to something else. However, that something else is almost always, we'll say, just to be cautious, better than the place you were. So I just want to, again, it's a cautionary tale, but it's to emphasize that I don't think our goal should be to restore Vermont to what it was hundreds of years ago, because I don't think that's possible. But what we can do through bringing in large carnivores that play these sort of really important roles is build a much healthier Vermont and move it in a direction to have a new Vermont that is built on healthier ecosystems. Does that make sense?
Absolutely, yes. Representative Tagliavia.
How do you do what you just said and avoid human cougar conflict? And what, in your view, is an acceptable level of that?
That's a great question. So if you have a healthy cougar population in Vermont, there will be conflict. I'll just be completely open about it. Most of that conflict, or almost entirely, is people seeing them and being afraid. And I'm just kind of comparing it to, say, Washington and other states I've worked in. So you get sightings a lot. And so a lot of it's sort of just an agency addressing the fear that people might have in seeing a large carnivore. It's about education. It's about rolling out a red carpet to kind of mitigate those potential things occurring, but helping people understand what it means to live with mountain lions. Are there real risks? What are the perceived risks? And then the other is really understanding how to protect our domestic animals. As I said, if they are in, quote, deer habitat, which all of Vermont essentially is, right, where people are living, that mountain lions are going to be hunting deer. in people's yards if they have white-tailed deer in their yards. And that creates this potential for conflict, which can absolutely be mitigated with some really simple training and some really simple tools. You've just got to put your animals in at night, dawn to dusk, in an enclosure with a roof. Always people ask me, how high should the fence be? Well, they can jump really high. Instead, I'd rather you just put a roof on it. Make it 6 foot high or 8 foot high and put a roof on it. That's the way to fully protect your animals. And then there is no conflict, or you can get rid of 98% of it. Human recreation, as I already said, it's such a non-issue that it really is about the perceived risks versus the real risks. And all of the work on all large carnivores suggests that that can be addressed through educational campaigns and really having a state agency or a wildlife agency, we'll say, embrace that educational component that is so necessary to preparing people to live alongside large carnivores.
I have another one. One of the things that we've heard questioned a little bit is sort of I guess I'd like you to speak to is the kind of the coarseness of your habitat modeling data, and how much of that might need to be redone in a feasibility study that would be more specific to Vermont and our contiguous states.
Yeah. So one thing I always say when you look at analysis like that is there's always, could we improve it? Is a great question to ask. And number two is it the best science we have? So are there always ways to improve the science that's been done? Absolutely. As a scientist, it's easy to be critical and to say, yeah, we can do it better if we just had this kind of data. Could we, for instance, if we had really detailed prey data in a particular region, boost the model? Absolutely. On the other hand, what we've done is without doubt the best science available, and that the resolution of the RSF, for instance, is 30 meters. So that's not an issue, resolution. The question is whether we could build a better model. And yeah, maybe, but I don't think that from a habitat standpoint, this is an animal that can live almost anywhere, in any habitat. And that's not the issue. Again, I would emphasize that people are the issue. You want to find the places where people are excited to see their return, are going to support their return, and are going to engage and cooperate and collaboratively come up with strategies to coexist with them peacefully with the State Wildlife Agency. That's what you're looking for, because they could be anywhere in Vermont. That's not a problem. Or throughout the Northeast, really.
And one last one, what would the estimated cost of the feasibility study, but also of maybe a 10-year plan, or the overall cost that Vermonters could expect from if we step forward in this direction?
A feasibility study, I would assess, would be really a staff member's time. You could contract out a tremendous amount of this work, some of which may be done volunteer. We certainly, I know you've heard from some folks willing to help shoulder the costs, so that it could minimize the costs for the people of Vermont. So it'd really be about staff time from a State Wildlife Agency, because it should be led or co-led by the State Wildlife Agency. And I would imagine that would look at about 18 months to complete such a thing. And so you're looking at, say, $200,000 if it was a full-time staff person. No doubt they'd be doing other things as well. And that you maybe add some additional sampling, like specific Vermont surveys and outreach. That's really what's lacking. The habitat part, I think, really there's very little more to do there. And so maybe say it's 250, 300,000, maybe a bit more than that to complete, all of which I know private individuals and foundations are willing to shoulder. A 10-year plan is different. So now we're talking about, let's say, a feasibility comes back from the agency and people of Vermont, legislators, the agency itself says it seems feasible. We've answered all the questions. We've talked to all the people. We've found a potential source for mountain lions. We've identified the place that we would release them, or several in the state that make the most sense. All of those things are checked off. Now you're ready to actually do it. So now you have a reintroduction plan, which again is a process. You build a plan that might take another year or so. And the actual release of these animals, there's some questions. Would you do a hard release or a soft release? Meaning, like, would you build an enclosure and feed them for 3 months before you let them loose into the wild? These kinds of things. So that, without doubt, could cost $1 million or $2 million. You know, I'm just thinking like the full introduction, catching animals, bringing them to Vermont, having them in an enclosure, releasing them, you know, monitoring them over time. You know, that's the big bill at the end. And again, I think you'd find huge enthusiasm for individuals and foundations to step up and support Vermont and shoulder the bulk of those costs.
More questions?
Representative Tagliavia.
Transfer of animals. File the future in and this is ready to go. How long would an animal need to be quarantined to be sure that you're not transferring some sort of a parasite or a disease from west to east?
That's a really great question. I'm not a veterinarian by training, so I would absolutely suggest a veterinarian weigh in here. What I know from my own work working with veterinarians is that we could probably, you know, do swabs at the rectal swabs. You can do nasal swabs. You can do lots of sampling. We can take a blood sample so that we can do all of that analysis and have the results back within weeks to really identify whether that animal might be carrying something that we're particularly interested in. So all of that can be done quick. You don't have to quarantine them and wait to see, you know, if something symptoms, you know, show up. We can actually test for them directly to speed up that process. And so I think you'd find it to be a much shorter time than, you know, the old days of like, let's wait and see if this animal develops something before we release it. Instead, we just directly test for it now and see whether it's positive.
Thank you so much for your presentation today.
Yeah,
really
my
great.
pleasure. And please feel free to call on me. I would be absolutely thrilled to support you all, the State Wildlife Agency, and anybody else who's interested in this topic at any time.
Great. Thank you again. Thank you.
Take care.
All right, members, we are scheduled to be back after the floor, either 2 o'clock or 10 minutes after the floor, whichever comes first.